Similarly, let's take the another important problem. Okay, look at the screen. It is asking like this. A rifleman who's together with his rifle has a mass of 100 kg, stands on a smooth surface and fires 10 shots horizontally. Each bullet has a mass of 10 grams and a muzzle velocity 800 meter per second. The velocity with which rifleman attains after firing 10 shots is. It is given like this. Mass of the man given 100 kg, number of shots n equal to 10, mass of the each bullet equal to 10 grams given, it is equal to 10 by 1000 kilograms, and the velocity of the each bullet is 800 meter per second. Then what is the velocity of the man after 10 shots are completed? That is the question. Here let us apply the law of conservation of linear momentum. Applying law of conservation of linear momentum, that is initial linear momentum must be equal to final linear momentum, but here the initial linear momentum is equal to 0. Therefore, final linear momentum must be equal to 0. Let's take another slide. Here we got final linear momentum is equal to 0. Here final linear momentum is mass of the man into velocity of the man into mass of the bullet into velocity of the bullet multiplied by number of bullets released or number of shots is equal to 0. Here mass of the man given 100 kg into velocity of the man plus mass of the bullet 10 by 1000 kg into velocity of the each bullet 800 into number of bullets released 10 equal to 0. From this 100 into velocity of the man is equal to minus, right, 10 into 800 divided by 1000. Here I can cancel these three zeros, 0, 0, 0. Finally, it is equal to minus 80. From this, I can write that, right, velocity of the man equal to minus 80 by 100 is equal to minus 0.8 meter per second. The negative sign in the velocity represents the man is moving back by the time the bullet is releasing in the forward direction. Let me write that point. The negative sign in velocity indicates as the bullet is moving forward, the man moving backward. So anyhow, velocity of the man equal to finally, right? You need not to take negative sign because there is no meaning of negative velocity. You take only magnitude of the velocity, that is 0.8 meter per second. That is the answer. Look at the options. Look at the option B. Option B is absolutely correct. Minus 0.8 also available, but that value you should not take. Here there is no meaning of negative velocity. Okay. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this. A man of mass 100 kg is standing on a platform of mass 200 kg, which is kept on a smooth ice surface. Mass of the man given 100 kg and mass of the planet given 200 kg, which is kept on a smooth ice surface. Okay. If The man starts moving on the platform with a speed 30 meter per second relative to the platform. Speed of the man given 30 meter per second relative to the platform means speed of the man plus speed of the platform equal to 30 meter per second. From this I can also write speed of the man equal to 30 minus speed of the platform. Then calculate with what velocity relative to the ice the platform will recoil. It means indirectly what is the speed of the planet with respect to the ice surface. Correct? That is the question. For that, let us connect the law of conservation of linear momentum, that is mass of the man into velocity of the man equal to mass of the planet into velocity of the planet. Mass of the man given 100 kg, velocity of the man I can write 30 minus velocity of the planet is equal to mass of the planet 200 into velocity of the planet. 30 minus velocity of the planet is equal to 200 by 100 into velocity of the planet is equal to 2 times the velocity of the planet. 30 minus velocity of the planet equal to 2 times the velocity of the planet. 30 equal to 3 times the speed of the planet. From that, the speed of the planet equal to 30 divided by 3 is equal to 10 meter per second. So, velocity of the planet with respect to the ice surface is 10 meter per second. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. It is asking like this. A spring is compressed between two toy carts of masses m1 and m2. When the toy carts are released, the springs exert equal and opposite average forces for the same time on each toy cart if V1 and V2 are the velocities of the toy carts and there is no friction between toy carts and the ground, then what is the relation between the velocity ratio and mass ratio? Very simple. Here the initial linear momentum must be equal to final linear momentum. Initial linear momentum is 0. Final linear momentum is mass of one toy into velocity of that toy plus mass of the other toy into velocity of the other toy. From this I can write that m1 v1 is equal to minus m2 v2. From this I can write that v1 by v2 equal to minus m2 by m1. Look at the options, right? v1 by v2 equal to minus m2 by m1. Option C is absolutely correct. Understood clearly? Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A system consists of three particles, each of mass m and located at 1, 1, 2, 2, and 3, 3. The coordinates of the center of mass are given that three particles are maintaining equal mass m1 equal to m2 equal to m3, that is equal to m. But the first particle is locating at a point 1, 1. Second particle m2 is locating at 2, 2. And third particle m3 is locating at 3, 3. From this I can write that x1 equal to 1, comma y1 equal to 1. From this I can write x2 equal to 2, y2 equal to 2. x3 equal to 3, y3 also equal to 3. Okay, that means here x1 equal to y1, x2 equal to y2, and x3 equal to y3. x3 equal to y3 equal to 3. x2 equal to y2 equal to 2, x1 equal to y1 equal to 1. Okay. Then the center of mass distance x for COM, center of mass distance equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. m1 equal to m2 equal to m3, m x1 plus m x2 plus m x3 by m plus m plus m, m into x1 plus x2 plus x3 divided by 3m. M is cancelling. M is cancelling. Finally, it is x1 plus x2 plus x3 by 3. x1 is 1, x2 is 2, x3 is 3 divided by 3. 6 by 3 equal to 2. Similarly, since x1 equal to y1, x2 equal to y2, x3 equal to y3, and m1 equal to m2 equal to m3, that is equal to m. Therefore, xcom equal to ycom, that is equal to 2. Therefore, the coordinates of the center of mass is 2 comma 2. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. A particle of mass 10 kg moving eastwards with a speed of 5 meter per second collides with another particle of the same mass moving northwards with the same speed. The two particles coalesce on collision. It is like this. One particle, let the first particle, is moving in the east direction with a velocity v1 equal to 5 meter per second, and its mass is m1 given 10 kilograms. There is a second particle also maintaining the same mass m2 equal to 10 kg, but it is moving towards the north with a velocity v2 equal to v1, that is equal to 5 meter per second. So the first one and second one both are colliding, joining together. Two particles coalesce means joining to become one more new particle maintaining m3 equal to sum of the two masses 10 plus 10, because mass is coming under conservable quantity 20 kilograms. Otherwise it is given 20 kilograms. We will move in the northeast direction. This third particle, this resulting particle is moving in the northeast direction at an angle. Northeast direction means this angle theta 3 is equal to 45 degrees. Now, with respect to east or horizontal, the first one is making 0 angle. The second particle is maintaining theta 2 equal to 90 degrees. Third one is maintaining 45 degrees. Okay. Then, according to law of conservation of linear momentum, mass is proportional to 1 by v cos theta. Okay. From this, I can say that m v cos theta is proportional to 1, or mv cos theta is equal to a constant. Is equal to a constant. That means it means m1 v1 cos theta 1 plus m2 v2 cos theta 2 must be equal to m3 v3 cos theta 3. From this you can decide the v3 value. Directly you are asked to decide the new particle velocity v3. What is the new particle velocity v3? Okay. Now m1 M1 10 kg, V1 5, cos theta 1 is 0 degrees, plus M2 also 10, V2 5, cos theta 2 90 degrees, equal to M3 20 kg, V3 unknown value, cos theta 3 is 45 degrees. Simplified. As we all know, cos 90 equal to 0. 0 and something 0. Then this is 50. 50 into cos 0 1 is equal to 20 into V3 cos 45 1 by root 2. 1 by root 2. So 50 equal to 20 by root 2. 20 by root 2 into V3. Okay. So that can be also written as 50 equal to 20. I can write as 2 into 10 by root 2 into V3. 50. This 2 in the numerator I can write root 2 into root 2 into 10 V3 by root 2. 1 root 2 is cancelled. 1 root 2 is cancelled. Finally it is 50 equal to, right, 10 root 2 into V3. From this V3 equal to 50 by 10 root 2. 50 by 10 is 5. 5 by root 2. 5 by, that is the velocity of the third particle, resulting particle, 5 by root 2. Look at the option C. Option C is absolutely correct. Understood clearly? I try to explain the each and every point at your understanding level. Okay? Similarly, let us take the another problem. Oh, completed. All the problems what we prepared completed. I hope all of you clearly understood all the problems what we discussed, right? Understood or not? Yes. Thank you. Thank you very much. Okay.